Hello, guys. What is up? Welcome to tonight's stream, and we are going to be having it with Astronomy Live. And today we are going to be doing a observation of Comet Atlas, which should be absolutely great because there's not a cloud in the sky, at least where I am. So, doing all the hard work will be Astronomy Live. How's it going, good sir?
Oh, it's going well. So right now I'm just tweaking the focus on the telescope, and then we're going to train the autoguider and the adaptive optics unit, and then we're going to proceed to the comet and observe it.
Awesome, awesome. Now, there is no cloud in the sky where I am. What about where you are right now?
Oh, it's beautiful, perfectly clear, and the forecast calls for clear skies all night.
Perfect, perfect, perfect. So, guys, thank you very much for joining us. Now, what we're going to be doing is we're going to be going live for about maybe an hour and a half, maybe 2 hours. Then afterwards, we're going to continue this observation, but on Astronomy Live's channel. So just stay tuned for that. I will be posting the link in the live chat for all you cool peeps, and that way you can head over there and continue watching on Astronomy Live's channel. But Astronomy Live, thank you so much for doing this on my channel because we had a request to do this on this channel, so thank you very much.
Yeah, thanks. I'm glad to be here, and it'd be nice to have somebody else assisting me with hosting duties. Normally, I do this on my own. It's a little tricky to manage a telescope and talk at the same time. I can't walk and chew gum at the same time, so oftentimes I'll just freeze and stop talking in the middle of it when I'm trying to focus on what I'm doing here with the scope.
It's okay, it's not your fault that you're a little slow. So anyway, tell us what we are looking at right here.
So we're just looking at the star that we're ultimately going to auto guide on. The camera has a built-in secondary CCD, a secondary chip that it can use to image, and it's going to do that on this star very rapidly to keep the stars perfectly centered and perfectly stationary in the view. I'm operating at the full 2-meter focal length of the telescope, and as you know from experience, at 2 meters of focal length, there is no room for error, and it is extremely punishing of any vibration. So right now we've got a single bright star that we're going to guide on. I'm gonna start up the process of training the auto guider on how to move. It's actually going to learn what the orientation of the camera is. The camera is designed to freely rotate and then get locked down in position so that you can find a guide star anywhere in a circle around where you're viewing. The auto guider takes off a piece of light outside of the main field of view, and you can reposition that field of view for the auto guider by rotating the camera. So I've got the camera rotated a certain way to get this star in the view, and now we're going to do the calibration process. So first I need to make sure I take out all the slack in the drives. So the drives have a little bit of backlash. Oops, wrong camera.
Basically, you mean there's gaps between the gears, right? They're not like perfectly flush with each other in both directions.
Oh, you're roboting the connection or my connection?
I think it was yours.
Okay, hang on.
All right. Sorry, guys. Internet's kind of being tested because of the you know what going around, so is what it is.
Well, and the problem is I didn't have the physical plug into my router in quite all the way on the laptop, I don't think. So it's defaulting to Wi-Fi. It
Ah, that would explain a lot.
says it's identifying the Ethernet connection right now. It's
Hmm.
identifying the Ethernet connection right now. So as soon as it gets done doing that, we should be good.
Well, let me try to say this again, and you can correct me. Essentially, there
Okay,
is slack between the gears. They're not perfectly flush in both directions, correct?
correct. So you have to take out the slack by moving the drive. There we go. So I drove the drive until it was showing that the star was moving. So I've taken up the slack, and that way the slack doesn't become part of the calibration. Still not identifying the physical plug. Let me try unplugging it, replugging it.
The ultimate Windows tech support solution.
Yeah, I do love this new laptop, but I do not like how they designed the Ethernet plug on it. It's pretty terrible. There we go. So it's working now. So I think we should be good to go. I don't think we should be roboting now.
Nope, you're coming through just clear.
Perfect.
Yeah,
Okay.
very clear indeed.
So now it's moving the telescope in all four directions to figure out how that star moves. It's monitoring how that little white spot moves, and it's saving that.
Well,
And it's
so as the star moves, the scope is going to move with it. So basically, there's going to be perfectly matching with the speed of the sky.
right. So it's trying to figure out how much it needs to move the motors in order to produce a motion in that star right now. It's calibrating that process. And you can see how much the slack affects it here. You have a value of 18 in Y positive, but when it went the opposite direction, it basically hardly moved at all because of the slack. So I just duplicate the value because it should be symmetrical in both axes. And because it didn't hardly move at all, it gets the angle a little bit wrong on, so this should be, trying to type in the dark here is a little tricky. Let's see. That should be, that's going to be 30. Yeah, something like that. 36 degrees. There we go. Okay, so now we've got the autoguider calibrated. Now we calibrate the adaptive optics unit. So this is a tilt-tip mirror system that runs very fast. So the motors of the telescope respond pretty slowly compared to this. This is a tilt-tip mirror that rapidly moves around in all four directions to keep the star perfectly centered very fast. So we can guide it multiple times per second, whereas with the motors, they can really make a correction once every second or two at best. So the motors respond much slower, but now with the adaptive optics, the only thing the motors have to do is make sure that they keep the star within the range of travel of the mirror. All right, so we've done that. We've got calibration done, so we'll go ahead and move the telescope to the Comet now, which is just about half a degree or two, maybe a degree away from where we're pointed right now. It's not very far away at all. So
Do it.
Reposition the scope so that auto guide star is nicely centered in the viewfinder, or in the, not the viewfinder, the auto guider. And the Comet will be in the bottom left corner of the view, but it's going to move over the course of the evening through the center of the view.
Now, as it moves, one person did bring this up in the comment section or in the live chat. How exactly are you correcting for field rotation? Because the image that I put up for the preview to this live stream showed that your telescope was an alt-as. How are you compensating for field rotation?
That's a great question. So right now the telescope is polar aligned. And actually, you can share the video I sent you. I can send it to you again on Hangouts here, so you can share it on the stream.
Mm-hmm.
That video I sent you earlier shows me aligning the telescope, or actually just setting the telescope up. And go ahead, don't share the link, but just download it to your computer.
Yeah, I gotcha.
And then share it on Hangouts. So the scope this time is set up on the wedge, so it is polar aligned. It's set up on an equatorial wedge and polar aligned, parallel to the Earth's axis of rotation, so we won't get field rotation. So I just sent it to you on Hangouts so you can download it and then put it on the stream so people can see the setup process.
Absolutely, absolutely. All right, let me do this real quick. All right, downloading right now. All right, guys, I am going to share my screen here in a moment. Let me do this real quick. All right, here we are. So this is a full screen view of the video that you sent. And here we go. So this is Astronomy Live setting up the scope. beefy tripod. So your telescope has the ability to change from an alt-az telescope to an equatorial telescope.
Correct.
That's neat.
So normally when we photograph rocket launches and things like that, I just set it up out as, because that's all you need for that. But when doing deep space stuff like this, I set it up equatorial with the wedge and parallel to the Earth's axis of rotation, so I don't get field rotation.
And all people are commenting that that's some serious gear. So why don't you tell us the gear that we're working with tonight?
Absolutely. So the telescope is an 8-inch Meade LX200 Classic. This is a Schmidt-Cassegrain telescope with a focal length of 2 meters and an aperture of 200 millimeters. And so it's an f10. The camera is an SBIG ST2000 XCM. It's a single-shot color camera. It's actually the same CCD that is found on the Mars Curiosity rover and the Mars 2020 rover. It's the exact same CCD with different electronics around it. The electronics around this camera, of course, are designed to operate in deep space for deep space imaging. It's thermoelectrically cooled so that the camera holds a set temperature. Right now I've got it set to negative 5 degrees Celsius. Even though it's pretty warm out here in Florida, it has no trouble reaching that temperature. So that allows it to reduce the thermal noise in the camera, and also because it's holding a very particular set temperature, this also means that the dark frames are well calibrated, because you really want your dark frame when you take a calibration photo where you close the shutter and you take a picture of just the blackness of the shutter closed, and you subtract that from all future images, because that contains thermal noise, it also contains hot pixels, and so it calibrates your photo so that you don't have those artifacts. By holding a set temperature, you get a much better calibration, because temperature matters. As the camera warms up over the course of the evening from being used, if it wasn't actively controlling its own temperature, those dark frames that you took at the beginning of the evening would no longer be valid, and you would get a poor calibration, and the image quality wouldn't be as good.
Now, how does it actually regulate its own temperature? Does it use a Peltier device?
It uses a thermoelectric cooler, so it converts electricity into a temperature differential. It's got a cold side and a hot side to this thermoelectric cooling device. The hot side goes, I believe, to a Peltier cooler, and eventually it gets dumped overboard by using a fan and just blowing the air out. It does have a water cooling system as well. I've never actually used it. The idea of pouring water through my camera, even though it's designed to do that with a radiator essentially. If that radiator springs a leak, though, you're in trouble. So I've never actually used it, because that just scares me to death. And honestly, it doesn't need it. It just increases the degree to which you can cool the camera. At negative 5 degrees Celsius, you're already eliminating a lot of thermal noise and improving the image quality.
Absolutely amazing. And with all these images that you would be taking tonight, do you stack them after the fact, or do you stack them in real time?
I stack them usually after the fact, but I can do it in real time with Deep Sky Stacker Live. In the case of tracking comets and asteroids and things like that that are moving, that all requires additional processing that I do after the fact. I actually did a video on my channel recently called Comet Stacking Made Easy, where I wrote a new program to automatically align the images on the comet based on the comet's orbital elements, and astrometry, where you solve the position of the image. You basically have a file that contains it allows you to determine the coordinates of every pixel in the image, the actual sky coordinates. And so then you can align them automatically based on where the comet should have been, based on its orbital elements. So that all requires, some processing after the fact. So when tracking moving objects like this, I just show the raw images, the individual frames.
And one person wanted to verify if you were the person that set me up with my new setup with the Nexstar 6SC, and I want to say yes, Astronomy Live, who is here, right now on the stream, is the guy that set me up with that, with the throttle and joystick and the program that controls all of it.
Yes, indeed. All right, we're ready to start actually taking pictures of the comet now, so I'm going to go ahead and configure the camera for that. It's already tracking the guide star It's getting really nice readings on this guide star. We
Perfect.
are we're guiding at 7.6 hertz. I can actually increase that quite a bit. This guide star is so incredibly bright. It's actually bright enough to theoretically be seen by naked eye, which is not normally the case. Normally, I'm having to work with something that's a lot fainter, um, but it can still do it. Uh, I try to aim for guide stars that are brighter than magnitude 10 in general. This one is magnitude 5.32, so that's within naked eye visibility. It's dim, but within naked eye visibility, so it's extremely bright to the camera.
For those of you who don't know, a negative number means brighter, and the higher the number, the higher positive number you have, the dimmer it is. Just want to make that
Exactly.
clear.
Yep.
And Christopher for $5 Australian says, "Too many big words. Jam is going to call this fake too."
Yeah, probably.
Nothing we can do about that, I guess.
Right.
And this telescope that you're using is the same telescope that you use to film like Falcon 9, Falcon Heavy. You use this exact same telescope to capture a continuous, uninterrupted shot of the first ever Falcon Heavy launch, the one that brought the Tesla to space.
Exactly. Yeah, it's the exact same telescope, just configured differently for deep space observations with the wedge.
That is absolutely amazing.
So, yeah, there we go. So we're guiding at 11.6 hertz. Theoretically, the maximum of this adaptive optics unit is 40 hertz, but with this computer, the computer I'm actually using to acquire the images is different than the computer that I'm connecting to the Hangout on, and it's not a very fast computer. So it can never seem to hit those numbers, but still, 11.6 hertz, that means it's making more than 10 corrections per second to the position of that star, holding it perfectly centered. So now we can begin taking the images of the comet, and away we go. So now it's going to take a 2-minute picture of the comet, and then it'll stop for a minute and take a dark frame where it closes the shutter and takes a 2-minute photograph with nothing in the image. And then it will subtract that from all future images. So the first image we're going to see will have a bunch of colorful pixels that are just defective pixels. Every CCD has them. They're hot pixels. And then it's going to take a dark frame to subtract from all future images, and then those will be cleaned up and look nice.
I see. And a question that doesn't really have anything to do with what we're doing here, but something that is to do with camera sensors is a lot of people seem to not understand why videos from like the International Space Station tours have those white dots, that electronic snow on the frame. Can you explain what that is?
So with the ISS cameras, and I've noticed it especially with their internal cameras that they use to film the astronauts with, they do tend to have a lot of hot pixels that are really severe. The radiation that's in space, cosmic ray strikes, are not filtered out they're normally filtered out by the atmosphere, but without the atmosphere, being above most of the atmosphere means that the CCD is exposed to a lot more radiation. And some of those particles can permanently damage individual pixels, causing new hot pixels to form on the camera. So the cameras that are on the space station tend to have more accumulated damage over time, over the years the space station has been in orbit, and so they show more hot pixels than normal. You'll also see a lot more cosmic ray strikes because, again, our atmosphere protects us from most of the radiation. Of course, our magnetosphere has a role to play too, but oftentimes those particles will get through the magnetosphere and actually collide with the atmosphere. And so once you get above the atmosphere, you're automatically exposed to more radiation. In fact, even if you take an airline flight at 30,000 feet, you can actually detect a higher level of radiation than you can at sea level. All right, here comes the first picture.
All right, let's see it.
All right, so I'm going to zoom out. There's our comet right there. How
Oh,
about that?
oh, that looks absolutely beautiful.
Yeah, that's not too shabby. So I'm going to zoom in on it. I'll have to move the. How am I going to do this? Tell you what I'm going to
Oh,
do.
we see it right there. We see it
I
right
can see it
there.
right there, but I want to be able to see my auto guider window as well. So I'm gonna have to zoom in on this guy so I can expand the window so I can actually click, and he's a very small window, so I got to expand him to allow me to grab onto him and drag him down here so I can position this window next to the comet window, and I'm just going to reposition this window just a just a hair.
That is an absolutely beautiful image. Now, I understand that there's going to be more processing that you're going to do with this image, but with what we see right now, that is absolutely gorgeous.
It is. It is. I'm very happy with that image.
So the atmosphere is like super clear tonight.
It is. It is. And the focus is perfect because I've I actually refocused the scope on the star that it's auto guiding on right now. So the advantage of doing that, when you move the scope a large amount in the sky, you can get mirror flop. The way the focuser works on the telescope is it actually moves the mirror up and down inside the tube a little bit. And so as you change the angle of the scope, gravity can actually pull on the mirror and cause the focus to shift. So it's always good to refocus the telescope when you get to your target. Fortunately, this guide star was super bright, and so it allowed me to easily refocus the telescope before moving it very slightly to the comet. So we're perfectly in focus. The atmosphere is perfectly clear, and getting some very nice images here.
That is absolutely gorgeous. Now, what's the next process or the next step? You're going to take a 2 minute long exposure of just nothing. It's just black because the shutter is
Exactly.
closed, right?
Right. It just did that. It just downloaded that, in fact, and so now it's going to clean up the image. And already there you can
Whoa.
see it much better now without the hot pixels. So there are some residual hot pixels that will be there. Taking a single dark frame is not the best way to do things. There's a lot of professional astrophotographers who would slap me in the chops for doing that because that's really not the best way to do it. You should take many dark frames and then average those together and subtract it. But for doing live shows like this, it's better for me to just take a single dark frame because then in CCD Soft, it can subtract it in real time and show these images live with at least a single dark frame subtracted, which gets rid of most of the noise.
How many dark frames would be enough dark frames?
I would say I would go for at least 50.
50?
Yeah. I used to do that. I used to do a dark frame library where you wait till after the evening's over because again the nice thing about this camera is you can set it to a particular temperature and it will go to that temperature and hold it. So it doesn't matter when you take the dark frames. So I would do it like the next day and leave it in the house and just have the shutter closed and take 50 dark frames times 2 minutes. That's 100 minutes. So an hour and 40 minutes just taking dark frames and then average all those together and subtract it from my images from the previous night. But that's the best way to do things, but that's not ideal when you're trying to do live streams, and you want
Yeah.
to show these images in real time. Just take a quick one, single dark frame and subtract it, and it's good enough. I mean, it gets you 90% of the way there.
There's that much variation between multiple dark frames?
Oh yes, as the camera runs over the course of the evening, you'll even see new hot pixels appear. Those aren't necessarily brand new hot pixels. It's just sometimes they turn on and turn off. I couldn't tell you why exactly, but they seem to be um, transitory or intermittent in nature sometimes. And so that's why you want to take dark frames over a period of time, many dark frames, and really get a good picture of what the overall noise profile looks like for the camera.
That I didn't know this, so I just learned something new today.
So now we're going to see the comet will have moved quite a bit because it took an additional 2 minutes to take that dark frame. So the comet jumps in position there in the new picture. I don't know if you noticed that, but if you watch the pictures when the new ones come in, it will move in every single frame. You'll see it moving from frame to frame.
Wow. Now, I understand the comment where we have it in the title, but just tell people what exactly we're looking at. What is the name of this comet, and so on.
All right, so the comet is named C2019 Y4 Atlas. Now, that name is mostly systematic. C2019, of course, refers to the fact it's a comet discovered in the year 2019. C indicates it's a long period comet. Periodic comets with short orbital periods have a P designation. And the recently discovered interstellar comets like Borisov, Comet Borisov has an I designation because it's interstellar. So C indicates it's a long period comet. 2019 year it was discovered. Y4 is the fraction of the year, the half month in which it was discovered. So that indicates it was discovered late in the year. I believe it was December. And then 4 is the number of comet within that period of the year. So Atlas is an acronym, actually. I believe it stands for I could get this wrong. I think it's asteroidal terrestrial last alert system, something like that. Asteroid terrestrial impact last alert system, I think, is like the name of the telescope that discovered this comet. It's a relatively new series of telescopes that are coming online to provide a sort of a last chance warning for any asteroids that might be on a collision course with Earth. So they're looking for moving objects throughout the night sky, and of course they're going to find comets in the process of doing that as well, like this one. But this comet has no risk of impact to Earth. The closest it's going to get to Earth is a little bit more than 3/4 of the distance to the Sun, about 0.781 astronomical units. 1 astronomical unit is the average distance between the Earth and the Sun. So no risk of impact. The orbit does not intersect Earth's orbit, so we're not going to fly through any meteor shower debris or anything like that. So it's not like I said, it's not a risk for Earth. It's not going to have any direct impact for Earth. But what is very interesting about it is the orbit is very, very similar to the Great Comet of 1844. So back in 1844, there was a comet that was observed that was naked eye bright, and it has an almost identical orbit. Of course, it's not the same comet. That comet is now on its way out from the inner solar system and will spend thousands of years in deep space. This comet has a very similar orbit, though, so that indicates it's probably a related object. They probably are fragments of what was once a singular larger object. So there's a good chance that this could be a big chunk. It could put on a good show, just like the Great Comet of 1844 did. So we're hopeful that it will become naked eye bright. It's already almost naked eye bright. My understanding is the latest measurements put it at about a total magnitude of 7.9. So that is starting to approach the level at which a very well-trained observer from very dark skies could see it with averted vision. I think the limit for human vision is usually around magnitude 7. Maybe some people could say they can see a little bit dimmer than that, but no more than 7.5. So it's getting to that level, but still, it's going to need to get a fair degree brighter before your average person is going to be able to see it in the sky. But it is projected to get that bright. The chart of its increasing brightness suggests it will hit at least magnitude -1 if it holds together. Now, the real big question is whether it will hold together. It's going to be approaching quite close to the sun, and so there is a chance that the sun could actually break it apart, that the level of outgassing, the level of material that's vaporizing off its surface will actually cause it to collapse and disintegrate. If it doesn't hold together, then we're probably not going to see much of a show. But it could turn into another comet Ison, which was again another comet that was projected to potentially get quite bright, but it fizzled out at perihelion. It basically disintegrated. So that could happen here again. So there's no promises, but it has the potential at least to get very bright. Some are even suggesting, I've heard rumors that they're saying, some calculations showing it to eventually become as bright as the moon. I think that's unlikely. Personally, I'm still skeptical of it getting that bright, but it might get bright enough to be seen in daytime. That's not unheard of.
You would be able to see this with in the daytime?
It has happened before. It's actually not been that long since we had a comet that was visible in the daytime. And I'm gonna butcher which comet it was. I think it was Comet McNaught. Was it? That was visible in the daytime. Yeah, it was. Okay. Yeah, Comet McNaught was a daytime comet, bright enough to be visible in the daytime in 2007, I believe. At least I found an article. Oh, no, it might have been an older article that got updated. When was that? But that was something like 13 years ago or more. And it mostly put on a southern hemisphere show. In this case, we have a decent chance of seeing it that bright from the northern hemisphere. So that's really exciting for us here in the northern hemisphere. Yeah, Comet McNaught, it was known as the Great Comet of 2007. The designation, it was discovered in 2006. It was C2006P1, but it became a Great Comet in 2007. So, yeah, it was actually visible in daytime. I didn't happen to see it in daytime. I found out about the fact that it was that level of bright a little bit too late, unfortunately. But I did see that one before perihelion, and it was definitely brightening rapidly. That's the kind of behavior we're seeing here, where it's sort of beating initial expectations, and that's why there's a hope that it will get to be naked eye bright, even potentially so bright that it's visible in broad daylight.
That would be amazing. And also, one person commented that you'll never hear this much science from a flat earther channel. And the fact is that Astronomy Live is really, really good at what he does. So if you guys have not subscribed to his channel, you're missing out. Please, I beg you, go to Astronomy Live's channel and hit subscribe, hit the bell, everything. Follow this guy because he knows what he's talking about.
Thank you. Appreciate that.
He
High praise.
and keep in mind that without him, the 6SE scope mount that I have for the Nikon P1000 wouldn't be able to do what it's able to do now with tracking rockets. So Astronomy Live, his software is running on my laptop. His software is the only reason it works. So I want to make that incredibly clear that Astronomy Live is the man when it comes to this.
Thanks, Red. And I'm personally looking forward to things kind of going back to normal, and us being able to go back to launches again at the Cape and film that together with my software running on both our laptops with two tracking mounts going after the rocket at the same time. That will be incredibly epic.
Yep. Let me ask you a very basic question. The comet that we're looking at right now, it's mostly water ice, right?
Not necessarily. A lot of the volatiles that are on a comet like this are, I mean, water ice can be present and often is, but the first things that start outgassing are usually more exotic, things that you wouldn't normally want to find in our atmosphere. Things like even cyanogen gas, which is basically cyanide. You can have molecular carbon that actually outgasses. Carbon monoxide can be present. A lot of nasty stuff, actually, you wouldn't want to breathe necessarily. But yes, later, as it gets closer to the sun, eventually it gets to the point where even water ice starts to sublimate. But some of these other volatiles sublimate at even lower temperatures, and so they start outgassing first and producing the color that we see in the comet. Now, what you're seeing right now is mostly probably dust and reflected light from the sun, the white color of the comet and its tail.
Yeah, we just saw it move right there.
Yeah, exactly. You can see it moving. As soon as each image comes in after 2 minutes, you'll see it in a new position as it moves. So, yeah, most of the light you're seeing right now is probably reflected sunlight in the dust that's coming off the comet. As these volatiles outgas, the ice isn't like just pure ice, it's just sitting out there on the surface like somebody dumped ice cubes. It's dusty, very dusty material, and this dust comes off with the gas. The comet itself has very low gravity. These objects are, at best kilometers in size, and so they don't have a whole lot of gravity. And so when this gas comes off, that dust comes off, and it doesn't fall back. Generally speaking, it will escape the comet. So that's where you're seeing most of the light coming from, is from the reflected light from the dust. But when we stack these pictures, when I align them on the comet and stack them, you'll see a fainter green glow all around the comet. This is the coma being generated by some of these gases that are actually coming off and being ionized even by the solar wind and solar radiation. And if you get enough of that gas getting ionized by the solar wind, it'll get pushed back by the solar wind and form an ion tail. So you can have an ion tail and a dust tail. Right now what we're seeing is primarily a dust tail.
I see. And I did want to answer a question. Dan74 asks, what's the little window to the left? That, I believe, is the guide star, correct?
Yes, exactly. So that's the guide star that is being tracked by the adaptive optics unit. So I'm, in addition to the SBIG ST2000 XCM, that's the camera, I also have what they call an AO7, also made by SBIG. This is designed to bolt onto the camera. It looks like a star diagonal. It looks like a device that angles the camera up 40, or actually 90 degrees from being straight off the back of the telescope. But it's much more than a star diagonal. It actually has a mirror that moves, and it tilts and it tips to keep that star perfectly centered at very fast rates. So if I actually switch over to the auto guide tab, you'll see the X tilt and Y tilt. These are the mirror positions, and you'll see these numbers change. You'll also see a guide rate. Generally, probably it'll hit over 10 hertz when it gets going here. Yep, there it is now, 11.8 hertz. And you see these numbers change, these percentages. This is how close the mirror is to traveling to the end of its limits. When it gets down to 0%, that's the limit of its travel, or 100% is, obviously the opposite direction. But it will move the motors of the telescope to keep itself within the range of travel that the mirror can hold it in position. But the mirror is doing most of the work, tilting and tipping to keep this star perfectly centered at very high speeds. This keeps all the stars in the main image very, very sharp because there's no drift. This is able to respond much faster than there would be any drift, or even compensating to some extent for the effects of the atmosphere. Even the atmosphere can cause the positions of the stars to wobble a bit. So it is actually compensating for that to some extent. Now, of course, it's not making higher order corrections that a segmented mirror would in a professional observatory. These big professional observatories have adaptive optics that are consisting of basically segmented mirrors, where the main mirror of the telescope is not just one piece, it's many pieces that are hexagonal in shape, or whatever shape they make is multifaceted, and basically each mirror has its own motors that turn and allow the mirror to the overall shape of the mirror to deform to offset the distortions of the atmosphere.
Is this exactly the type of technology that's going to be implemented on the James Webb Space Telescope?
Um, the James Webb Space Telescope is segmented, but it doesn't need to deform in order to adapt for atmosphere, because of course it's in space. So there's no need for adaptive optics if you're already in space. But they needed to make the mirror segmented in order to fold it up and fit it inside the rocket for launch.
I see.
So, but the professional observatories you find on Earth on the ground often will have, the newer ones will have segmented mirrors, not only so that they can make a really big mirror, but also so that they can reposition each of the individual segments to basically compensate for distortions in the atmosphere and get a higher resolution image than would normally be possible. It's like you're compensating for the existence of the atmosphere and eliminating it from the images. Again, my telescope does not have a segmented mirror, so it's not doing that level of correction. But even with a single mirror tilting and tipping, you're able to compensate for some of the gross movement of the stars as a result of the atmosphere, and also completely eliminate any tracking errors or any imperfections with the motors. The motors of the telescope, of my telescope in particular, are not perfect. This is an LX200, which is still a high-end scope. Back in its day, when it was made in the 90s, like, this was the high end of amateur telescopes. But nowadays, it's much lower on the scale. You can get a very nice mount that doesn't even need this level of correction, where the gears are very, very finely machined and very, very perfectly round. The gears on this telescope are sort of mass-produced, and so they're not exactly perfect. And because they're not perfectly round, sometimes the gear will move a little bit faster than it should, or a little bit slower than it should, causing a back and forth drift in the position of the star. Even if you are perfectly polar aligned, the star will appear to drift back and forth due to the imperfections in the gears. This is able to compensate for that much faster than the gears themselves could, because you can just do regular auto guiding, where you're telling the gears, hey, you're moving too fast, slow down, or you're moving too slow, speed up. But by the time the gears have actually taken out their own slop, their own slack, that backlash, you've already streaked your image. The stars are no longer perfectly round. So this is able to respond much faster than the gears could, and completely compensates for the fact that I'm using a mount that is normally not capable of photographing with images exposures this long at this focal length. Because as you know, Red, at 2 meters focal length, you even breathe on it and it will shake.
Yeah,
So any imperfections in the motors would normally blur the image, especially at this focal length.
which is kind of why I needed your assistance, because at the zoom levels that I was working at with filming rocket launches, even my pulse was coming through on camera. So your software really helped me out there, because boy was it smooth the last time I went out to film the Falcon 9 for the Starlink 5 mission.
Yes, exactly.
And also, I did want to ask you a question. He's Astronut66. Do you guys know the inclination to the ecliptic of this comet's orbit?
Yes, I believe it's about 45 degrees. Let's see here. Yes, according to Sky Safari Pro, 45.39 degrees. That is the inclination.
Now, for those of you who don't know, the ecliptic is what exactly, Astronomy Live?
That is the plane of Earth's orbit around the sun. So this comet is highly inclined to that plane. It's not orbiting in the same plane with all the planets. The planets generally tend to orbit within the plane of the ecliptic. Some are a little above or below, but some are a little tilted. But 45 degrees is a very high level of tilt.
Mm-hmm. Now, how exactly do they get that tilted? Because normally, the way I was taught is that when the sun was forming and you had that ring of dust that would eventually coalesce into what would become the planets, and everything kind of started from that accretion disk. How do you get all these wild orbits out of that?
Right. So that definitely applies for the planets, but these comets are coming from what is thought to be the Oort cloud, which surrounds our solar system in all directions. And I don't know enough about stellar formation to give you the rundown of exactly how that accretion disk transitions into a phase where you have material forming, all around the sun. But certainly these comets are coming from a region of space that is very far separated from the sun, out where their orbital velocities, in order to orbit around the sun, are very, very low. Um, but we know it is associated with our solar system, unlike interstellar comets, which are much rarer, like Comet Borisov, which came through here pretty recently. That one had an eccentricity that was above 3. It was extremely hyperbolic. It was not sharing our solar system's velocity around the galaxy. It had its own velocity as it passed through the solar system. It's like it didn't share the momentum of the sun. These comets do, and so as they fall into the inner solar system, we tend to find that these long period comets have eccentricities very close to 1, where they're nearly parabolic, but the sun's gravity is strong enough to just barely hold on to them. So that tells us they're coming from very far away, many, hundreds of AU away or more in some cases. So they come from deep, deep in the solar system. The semi-major axis of this orbit, I believe, is over 300 AU. Now, for perspective, even the Voyager probes haven't quite reached half that distance. So
300 astronomical units.
yes,
Wow.
yes. So these are coming from very deep in the solar system, and it doesn't take much velocity to orbit the sun at that distance. As you get further from the sun, orbital velocities decrease. So it doesn't take much to kick them into an orbit where they fall into the solar system. It doesn't take much delta V, right? It doesn't take much of a change in velocity to drastically change their perihelion distances, and they can get kicked into the inner solar system. Now, when that happens, it is possible for them to essentially pick up an unintentional gravity assist from the planets and actually get kicked out of the solar system altogether. That does happen sometimes. But even when that happens, we generally find their eccentricities are not much greater than 1. If we find that they are coming in with eccentricities that are already much greater than 1, that tells us that this comet did not start in our solar system and had to have come from a source outside of our system. So that's the case with Oumuamua, and it was the case with Borisov.
Yeah, so looking it up online, Voyager 2 is 118.279 astronomical units.
Right, right, and that's just the semi-major axis, I believe, is um, 312 astronomical units. That's not even the aphelion point. But the orbital period of this comet is over 5,000 years long, 5,500 and almost 20 years, according to Sky Safari Pro. So yeah, it takes this comet a long time to go around the sun, which also answers another question that comes up quite frequently, which is, well, if these comets have a limited amount of volatile materials, a limited amount of ices, how are they still outgassing? Well, they spend most of their orbit too far from the sun to experience enough heating to outgas. They only spend, a year or two at most close enough to the sun where they're experiencing this outgassing behavior. Most of their lifetime is spent in deep space, basically in deep freeze, where those ices are not being sublimated away.
So I didn't expect us to debunk a creationist myth. Congratulations. I didn't think we're going to arrive in this territory, but here we are.
Yeah, unfortunately, I think Kent Hovind likes to rail against the existence of the Oort cloud, and I didn't even know that was a thing. I didn't know that was like this fierce belief that some people have that the Oort cloud doesn't exist. And so I started getting these comments a while back. I forget which comment it was on, but they're like, the Oort cloud doesn't exist. I'm like, what?
Hmm.
What? What? Why would you say that? I was baffled at first. I'm like, why? Why? And apparently, I guess it was like,
Oh, we have a question. So the
oh,
question is, can you use your equipment for blink comparisons to make new discoveries?
oh, absolutely, absolutely. Um, and so one of the things I've done recently is write a program for automatically processing these files. So what it's doing when it's taking these pictures, it's saving them as raw FITS files, FITS, and this is a standard format in astronomy. It's used all the time by professional observatories. Even Hubble saves its images as raw FITS files, which is just a binary uncompressed format that has header data similar to what you would find with metadata on an EXIF metadata on a camera, but it's a different format. Um, and I've written a program to convert them into individual frames and even videos using tone mapping. These are also high bit depth files. These are 16-bit files, whereas most monitors, including the ones I'm using tonight, are 8-bit. Display 8-bit images. So you're only looking here at a portion of the dynamic range, not the full dynamic range of the image. So you have to do tone mapping to convert it down to an 8-bit file and also put it into a video, and then I can play that video and actually see the motion of this comet or potentially discover new asteroids as well. Although my scope is not so big that it's likely to be very good at discovering asteroids, um, because all the asteroids that are within the range of the scope's capability of seeing are pretty much going to be discovered by professional surveys like Atlas, like Pan-STARRS, these really big scopes that suck up huge amounts of the sky and discover these asteroids as they fly by Earth. However, it is possible, especially to find comets. Comet Borisov, this interstellar comet, was found by an amateur astronomer. Um, so it is possible to discover new objects, particularly comets. The reason being that oftentimes the comet is bright enough to be seen by an amateur scope, but may be positioned in an area that the professional surveys are not really looking. They come from very high inclinations. Also, they can be found close to the sun in the sky sometimes. And so, if you're looking low over the horizon in the early morning or early evening hours, you can search areas of the sky that don't tend to get as much coverage from the professional surveys. And that's where you find the chance to potentially discover a new object, possibly, oftentimes, a comet.
Here's a good question. If I went outside right now with my Nikon P1000, obviously it's not going to be as good as what you're showing us right now, but could I actually image this thing and it be somewhat usable?
Um, that's tough to say. I mean, this comet is just below naked eye visibility. So your Nikon P1000, I haven't really seen it in action in terms of doing long exposure photography of the stars. It would need to be able to detect the very dimmest stars the human eye can even see
Yeah.
to even have a chance of detecting this comet. I don't know that the sensor is really good enough for that.
People need to understand this is that the Nikon P1000, as good as it is, or for what it is, I should say, is not the best camera on the market. People think that it's this miracle camera. It really has its limitations. What Astronomy Live is using is kit that is actually usable for what we're trying to use it for.
Yeah, this kit is very, very specialized for deep space astronomy. It's not even specialized for planetary or lunar astronomy. Like, this camera would be terrible at trying to take pictures of the moon right now. The moon was up tonight, and actually I did take a picture of it. I should try to share that on stream here. But that was with I took that picture with my Canon, because believe it or not, my little Canon T5i SLR, although it's a lower tech camera in some ways. It doesn't have the adaptive optics. It doesn't have the thermoelectric cooling. It's actually much better at taking pictures of the moon than this camera would be. This camera is specialized for sensitivity and controlled temperature, and the adaptive optics only works when you're guiding on a star. It doesn't work when you're trying to take pictures of the planets. you need the autoguider to be able to see a star and track it very rapidly. So it's a very specialized for this task, but the P1000, unfortunately, the sensor on that is just not very sensitive. It might be able to see the comet if you crank up the exposure to 30 seconds, and I don't know, maybe, but it wouldn't look very good, I don't think. It certainly wouldn't look this good.
Now, they want me to repeat this. So yes, the camera that he uses for rocket launches is a Canon T5i, Canon Rebel. They call it a Rebel T5i.
Yeah, sometimes they call it a Rebel. Uh-huh.
Yeah, the Canon Rebel T5i. So when you guys see us dual streaming, so when we have two shots of the same rocket on the same live stream on this particular channel, he's using his LX200 telescope with the T5i. I'm directly broadcasting from the Nikon P1000 because the P1000 is good enough for rocket launches. Plus, it also results in other stuff that we will not go into.
Yeah. No, the P1000 is very good for rocket launches, I think. It's good for those bright shots of daytime things, or even night launches. But the thing you'll notice about it, even on night launches, if you watch the boost back burn videos from your camera versus my camera will pick up more of the faint outer regions of the boost back burn in the so-called SpaceX nebula than your camera will.
Yeah.
Because again, even my Canon T5i is more sensitive to low light conditions.
Mm-hmm. Yeah. Listen, I'm not using the P1000 because it's the best camera for the job. People need to understand that right now.
Right.
It is not the best camera for the job, but you know what? It gets the job done, and I like that. I like it about it. And also, even though the camera can't pick up the really faint glow of the SpaceX Rainbow or the SpaceX Nebula, they're calling it, it does show a very clear shot at liftoff, because for your camera, it will overexpose just a bit. Of course, that can be taken down in post and fixes the problem. But the footage right out of the camera, it's more pleasing to look at, I guess, straight from the camera without any post-processing. But of course, you can just fix that in post after the fact.
Right.
So P1000 has its limitation, guys, is what I'm trying to say.
Right. So I'm gonna send you a photo that I took of the moon earlier this evening with the Canon T5i.
All right.
I'm gonna throw it up on Google Drive and just send you the link here on the Hangouts, and it's almost done. So this again was taken with the scope really before I did the proper polar alignment on it. This was just eyeballing where I thought north would be, and just very rough. It really was not well aligned yet, but it shows you that the moon looks roughly vertical in the view. And looking at the moon right now, anyone in Florida looking at the moon in the west, you'll notice it looks like a Cheshire moon. It looks like a Cheshire cat smiling in the sky. It looks like it's tilted over on the side. So this is due to field rotation. And when you share the picture I took through the scope, you'll notice it looks roughly vertical.
Yep,
contrary to what you see.
Getting that up right now, and it's going to be showing in 3, 2, 1. All right, people are seeing it right now.
Cool. So yeah, I think that's a pretty good view there of what the scope can do. This is actually trying out with a new focal reducer I just bought off eBay, and this focal reducer attaches directly to the Canon camera and allows me to have the focal reducer on there with the camera on the star diagonal. So it comes out quite nicely. I think you get the whole moon in view there. You can see the craters and stuff.
That is a beautiful image, and you can see the shadows, of the craters right along the terminator. It looks really good, really, really good, and it shows that the moon is in fact a spherical object.
Yes, indeed.
I want to make sure that people understand this, because I think they might have tuned out. This clearly shows that the moon is a spherical object. Just want to make that very clear. Very clear. And going back to the live stream, and let me bring that back up. All right, live stream is back. And oh wow, it moved again. Look at that.
Yep.
Oh,
Yep.
there it is. There it is.
Yep. That comet's in motion for sure.
Now, once you have all this, afterwards, you can actually make a time lapse of all these shots, right?
Absolutely. That's the plan, is to time lapse this stuff to really show the motion over time. So it is moving mostly up in the view, but also slightly to the right. And by about 4 a.m., it's going to be hitting the top of the top of the view. I don't know if I'm going to stream that entire time. I might over on my channel later in the evening. But yeah, it's going to keep moving, and eventually I'll make a time lapse of its motion. So yeah, let me do one more thing here. I'm going to take a picture of the setup using my Pixel 4 and just give you guys a view of what it actually looks like all set up and running here.
You didn't make very good decisions, but at least you got the right phone.
Certainly for this type of work, right?
Yeah, getting a car, you made the wrong decision. Living in the ass of nowhere, you made the wrong decision. But getting a phone, you made the right one. I'm proud of you. Let's see. And just so people are aware, these are 2 minute long exposures. And the small box to the left, that is the guide star. So as that star moves, the scope and the adaptive optics is going to move to keep that star right in the middle of that box. That's how you know the scope is moving at the same speed as the sky above it.
Yep.
And you're going to send me the image from your Pixel, right?
Yeah, it's taking a 4 minute exposure right now, actually, in astrophotography mode. So it's going to take a picture of me sitting here with my telescope going.
Oh
And,
yeah, that's right. It has such a thing.
yes, exactly. So
you actually duct taped. I'm not sure what you did, but you duct taped like the lens of the Pixel 4 to your scope, and you took some epic shots that you posted on your Twitter account, didn't you?
oh yeah, I didn't duct tape. That was actually with a cell phone adapter, just a standard cell phone adapter. To be able to...
It was a cell phone adapter made of duct tape, right?
No, it was made of metal and plastic, but yeah, it was a Meade cell phone adapter that I used to attach it to an eyepiece, looking through the telescope and taking shots. And I've been rather impressed with what it's able to do in those situations.
One thing Google did right was the camera on that phone. That has got to be the best smartphone camera in existence, period.
I certainly think so. It does the best with low light shots, and the astrophotography mode is actually useful. It's not just a gimmick. I thought going into it, I was skeptical. I thought it would probably just be sort of gimmicky, but no, it's not. It's actually useful. So I've been quite thrilled with it, because especially in situations like this, I don't necessarily want to drag out my SLR and the tripod and all that. I could just take the cell phone, slap it down somewhere, and take a 4 minute exposure and see the stars and everything else. And the sad thing is, I've done side-by-sides. I need to put this in a video. I really do. I need to put this up on a video on my channel. I've done a side-by-side comparison of my Canon T5i using long exposures with that compared to the cell phone. Guess what? The cell phone looks better. The pictures I'm getting out of the cell phone of wide-angle shots look better than the kit lens that comes with the Canon T5i, and that's supposed to be a dedicated SLR. That's insane. Yes, the cell phone's got no business beating an SLR, but it does, at least with the Canon T5i.
That it just goes to show how good that camera is. That camera on that cell phone. I want that cell phone. That's what I want. Not only does it not have a notch that every single phone happens to have nowadays, but it has a camera that's actually, well, worth it.
Yeah, exactly. It actually is a pretty darn good camera.
And when is the aphelion for this comet?
You mean the aphelion or the perihelion? Perihelion is
A-
closest to the sun.
Aphelion.
5,000 years from now? I don't know. No, not 5,000. I guess half that distance. So 20, 2250, 2,250 years, something like that, probably.
In the perihelion.
Perihelion. Let me look that up real quick. Let's see. Looks like it will be May 31st.
May 31st. So only a few days away.
Yep. Yeah, basically, just a couple months from now.
Oh wait, yeah, no, I
May,
got that
not
wrong.
not March.
Yeah,
May.
okay, I got that after April. Okay,
Yeah.
all right, yep, I stand corrected. Now you
So
said
yeah,
that there's a risk that it might actually break up, though, right?
there is. Yeah, it could potentially. So yeah, we'll have to keep an eye on it and see if it holds together. If it holds together, it has the potential to be quite bright in the sky, which is what everyone's so excited about. But yeah, the other thing is the Earth minimum orbit intersect distance. This is how close the orbit of the comet gets to the orbit of Earth. Is only 0.63 astronomical units. So the orbit does not directly intersect Earth's orbit. It stays more than half the distance from the sun away from us. So even if it breaks up, the debris has no risk of hitting Earth, and we have no risk of driving through that debris because our orbit does not intersect the orbit of the comet.
Do we know the velocity at perihelion?
I'm sure we do. I don't know off the top of my head what that is, but the perihelion distance is only about 0.25 astronomical units, about a quarter of an astronomical unit. So it gets quite close to the sun compared to Earth. But I couldn't tell you off the top of my head what the velocity is. I'd have to look that up on JPL or something.
Do we know how big this object is?
To my knowledge, I don't know that they've actually figured out what the physical size of it is. Um, I don't think there have been any radar observations of it yet. None that I'm aware of. There might be, but none that I'm aware of yet. So it's hard to say. It could be a number of kilometers in size. Hopefully, it is. That means it's got a better chance of holding together. If it's smaller, but if it looks bigger than it is, if it's actually a smaller nucleus that's outgassing more, it may not hold together.
I see. And we already answered this question, but we're going to ask it again. What would cause this object to break up?
So, as the volatile materials, the ices on this comet outgas, it is possible for sections of the comet to collapse or even break up. If it runs out of volatile material, what will usually happen is it just sort of breaks up, and the last of that gas will sort of outgas, and then it'll fade out. You see this happen quite often with comets that are in the process of breaking up. They'll brighten up initially because they're actually in the process of breaking up, and that increases the surface area. So ices that were hidden in the core of the comet are now exposed, but those don't last very long, and ultimately the comet fades out.
And also, one person, Mr. Sirius, says a lack of communication would cause a breakup. That's that.
Communication is key.
That's clever. That's very clever. You get the gold star for the funny comment of the night. That's very clever. That's really clever, actually. Okay. Okay. You know what? It is what it is. uh, uh, Yay, I did it, says Mr. Serious. Yeah, you made us laugh. Congratulations. How long will you be observing this object? How many days do you plan on doing observations of this object? And what can we expect at the end of this period of observations from you? What can we expect to be posted on your channel?
So, what I'm working on now is trying to put together a program to make it easier to get the astrometry of this comet formatted in a format that I can load into Orbit Solution software and actually independently calculate the orbit of the comet. What I'm also going to do is, of course, keep observing it over time. And so whether it fizzles out or brightens up, I'm planning to just keep collecting images and streaming it. The let's see, peak brightness we are expecting probably near perihelion. I'm loading up aerith.net right now. It's a great website for getting information about comets. Let's see. Just heard the gears sort of take up some slack or something. It looks like the auto guider's still cranking
See,
away
it's
there.
it's not, and that's something that I have told people about you, and no one believes me. You can just hear something, and you know that something's off, even if the information on the screen isn't indicating such.
Yes, I know what my scope's supposed to sound like. It's got its own little quirks, and I know when I hear noises generally what it means. And I heard the gear sort of slip there a little bit. I think it was probably firing up the motors to keep. So these X and Y tilt values are showing how much the mirror is tilted, and it will occasionally move the motors to make sure that that the star that it's tracking stays within the range that the mirror can tilt, because the mirror has physical limits that are pretty tight actually. So it's got to move the motors once in a while to keep that star within the range where this mirror can tilt.
I
So
see.
anyway,
Now, one question that people have asked me in the past is, why does your telescope make that high pitched tone when you're tracking rockets?
so my telescope was not designed to track rockets and was not designed to work with a joystick.
Can
Um,
you say that again, just slower?
my telescope was not designed to work with a joystick, and it was not designed to track rockets.
Exactly. That's why I keep
And
telling people.
and so I came up with a hacky sort of solution to make it do what I wanted it to do. The problem with this telescope is that it does not allow you to directly control the drive rates. There is no command I can feed this telescope that tells it, I want you to turn this fast in this axis and this fast in this other axis. It's got, two main motors. When I mounted out as to track rocket launches, it's got an altitude motor and an azimuth motor, but I have no direct control over those motors. The newer LX200s do give you that control, but not the LX200 Classic. And so I had to come up with a solution to make it work with the joystick. And that solution was to basically feed it um, phantom points to chase after. It's like putting a carrot on a stick out in front of the telescope and telling it, go find it, go get it. And I'm just sending a continuous stream of go to commands. And so, what the scope will do when you issue a go to command is it will slew to the target that you tell it. And then when it gets there, it beeps, goes beep, it just a momentary beep. But because I'm sending it a continuous stream of go to commands, that beep turns into a long tone. And so it's just constantly beeping. Wee! It just does that the whole time. As long as the mode is engaged that it's receiving this continuous stream of go-to commands, it will emit a continuous tone. And so, although that's annoying, I've learned that I have to let that stay there. The problem I had during the in-flight abort test was that I unplugged the hand controller to silence that tone. The telescope's computer is not in the hand controller. For the LX200 Classic, the computer is in the base of the telescope. The motherboard actually takes up the entire base of the telescope. And so you can unplug the hand controller, but you haven't unplugged the brains of the telescope. It'll keep working as long as the hand controller had been plugged in when you turned it on. So you can silence the beep, which comes from the hand controller, by unplugging the hand controller. However, there's a risk, there's a chance that when you unplug the hand controller, it screws up the computer inside the telescope. And if that's the case, the behavior of its tracking gets really wonky, which happened on IFA for me. So I had to take over manual control of the telescope early in that launch and sort of fight it the whole way up. I mostly got it, but it was really challenging. So I'm never doing that again. So unfortunately, in my videos, there will always be that tone. Fortunately, on the plus side, I know what frequency the tone's at, and you can silence that frequency. It does degrade the audio quality a little bit to have this gap in frequencies, but in my opinion, for my videos anyway, I've made the judgment that it's worth the trade off.
Now, my setup, the 6SC Celestron, doesn't make that tone. Um, and I'm guessing is because the Mead and the Celestron, they talk to your program differently. Is that a good way of phrasing it?
Yeah, the Celestron is set up to allow me to directly control the drive rates. They have a different language they speak. My telescope's language doesn't allow me to tell it how fast to turn the motors. Your telescope's your mount's language that it speaks, the Celestron programming language, effectively, uh, does allow me to directly control the drive rate. So my program can simply tell your mount, I want you to turn this fast in this direction, this fast in this direction, and it will do it. So there's no tone because it's basically designed better to work with my software.
I see. I see. So, one question that I think people would have is if you have the ability to auto track these rockets, could you do something like that with my setup? And would it technically be smoother and or better in the final result?
Um, I could set it up to track these objects like this comet. Um, it would not necessarily be smoother because this adaptive optics unit cannot be underestimated. This thing is extremely powerful and allows even my mount to punch above its weight and basically get better images than it has any business getting. These
Ah,
stars here, you see how pinpoint these stars are on the main
yes,
image.
yes, I've seen that. They are solid. The only thing moving is the comet.
Exactly. Exactly. The only thing moving is the comet, and the stars are perfect little pinpoints. That is normally not possible, even with auto guiding with my mount, because the mount's gears are not perfect. Your mount, unfortunately, is at an even lower class in terms of the mass manufacturing, and the gears are not as large. And so, even if it has the same tolerances on manufacturing, because the gears are not as large, it produces a larger problem in terms of how much drift you get in stars when you're tracking the stars. So, yours is not as capable for deep space astrophotography. It's good enough for visual observing. If you put a telescope on there and you wanted to visually observe this comet, you could, and you wouldn't notice the drift by eye. But when you're taking exposures that are measured in minutes, even the slightest bit of drift at these high focal lengths will show up. So the adaptive optics unit is really um, basically eliminating those problems from my scope and allowing me to get these very pinpoint images.
One person comments, "Why not just remove the piezo from the controller that is making the beep?"
Um, because I still like to have the ability for my controller to beep. Yeah, I could just I guess unsolder the speaker from it and just turn it off that way. But honestly, I mean, I use it when it's in its normal mode, like tonight, and I'm using it like a normal telescope. I need that beep. I need to know that it's completed the slew, because what it'll do if I tell it to move to an object, it'll initially go at a high speed, and then as it gets close to the object, you hardly hear the motors anymore. It gets very soft, and it centers it up the rest of the way. The beep lets me know it's done and it's ready. So the beep also, even the tone, accidentally provides a beneficial effect to me when testing my scope, or just even operating it with the tracking, because it's like a heart monitor. It tells me the scope is receiving a constant stream of slew commands. If I hear that beep become a staccato or there's interruptions in it, that means my computer's thinking, or my computer's doing something that is not transmitting the commands as smoothly as it needs to. So it kind of gives me reassurance that everything is working properly with my software.
Can you mod your setup to toggle the beep?
Suppose I could. I'd have to drill a hole in the case maybe and install another button that silences it. I don't want to do that kind of modification. So one of the things about this scope is it's a very old scope. I've had this scope for 16 years now, as of this year, and it's they don't make it anymore. They make new ones, yes, but I like my classic LX 200. It's expensive, and I don't want to have to replace it. They don't
Hmm.
make replacement parts for it. If the hand controller dies, or I burn it up, or I damage it, my only option is to look on the used market. And hand controllers in the used market are actually very hard to come by because, unfortunately, the capacitors in the hand controller have a tendency to sometimes blow up. And if that happens, you're on the market for new hand controllers. So, used hand controllers in good condition are hard to come by and expensive. I have one in my closet, and even that one's not fully operational. And that cost me, I think, close to 200 bucks.
One person said, "Would you be able to change the beep to a light?"
Um, Again, I could, but all of this requires physically modifying the
Yeah,
board on the hand
modifying
controller.
You don't want to do it because I guess your setup they just don't make it anymore because you said it's a classic, right?
It's a classic. Yeah, they don't make it anymore. There's no replacement parts available. It's just too risky for me. I'd rather do no harm to it. The telescope isn't just used exclusively for rocket tracking, so I'm not going to start gutting parts of it for that purpose.
Yeah. Now, I do want people to correct something right now. Um, the footage that was shown on my channel, I see this happen all the time. I was not the person to film the first ever Falcon Heavy launch. I had to work that day. Astronomy Live, though, was the one that filmed the first ever Falcon Heavy launch, and it's a continuous shot from launch to landing. I highly recommend, that you go over to Astronomy Live's channel and watch that video because it is amazing. It shows the capability of his setup. And while you're there, please subscribe and hit the bell. Please follow Astronomy Live because, like I said, if it wasn't for this guy and me bugging him at all hours of the evening, I wouldn't be able to have my setup working as well as it is.
There's a question here from, or I guess just a point made by My Carolina Skies. And side note, that screen name sounds familiar. Are you on Cloudy Nights forum? Anyway, he says there's some new parts available for the classics. A new hand controller is about $140. An aftermarket niche company is making some bits, not from Mead. I wasn't aware of this. Could you send me a link on that? That sounds really interesting. I'd like to check that out. Assuming it's not a AutoStar mod. That I know several people who made kits for replacing the electronics on the Mead LX200 Classic with newer AutoStar parts. I really don't want to do that. A lot of those mods involved lower end AutoStar hand controllers that aren't even as good as the newer LX200s. So don't want to go there. And I've also seen some of the boards they ship with that, where it's like it's ugly. It's ugly. It's an ugly sort of glued up patch job. But maybe there's a new company that's actually making a nice one that is compatible with if it's compatible with the original Mead LX200 Classic board, that would be fantastic.
I mean, if you were to get like this aftermarket piece, and let's say the aftermarket piece, you can get them whenever you want. Would you be willing and able to modify that one to get rid of the beep and maybe replace it with like an LED?
Yeah, I'd be willing to try that at least. If I'm not having to modify my original hand controller, and it's another part that I could at least theoretically order if I burn it up for a reasonable cost, and like there's not a supply issue with it,
Mm-hmm.
then that'd be a good way to go.
Yep. And Cheshire is currently spamming the link to Astronomy Live's channel, so please go over there and hit subscribe and tell him that Red sent you.
Yeah, thank you, Chesh, appreciate it.
So, and also, I want people to understand another thing about Astronomy Live setup that he hasn't mentioned. Or maybe we have, but we haven't talked about all that much. Location, location, location. We're not going to dox this location, so I'm just going to say that he lives in the middle of nowhere. So the lack of light pollution is also helping you out in this case.
Absolutely. Yeah, you can see how dark the background looks here in these 2-minute exposures. If I was doing this from, downtown Tampa or something, it would not look this good. I don't even know if I could get a 2-minute exposure out of it without overexposing it just from the sheer amount of light pollution.
Now, light pollution would cause what? Would it cause a yellowish tinge to the image, or what would you see?
Yeah, it would generally cause a yellowish tinge, and the background light level, just the the area all around the stars would be much higher. The brightness of the image would go up, and that would start to obscure the tail of the comet, and maybe all the way up to the coma, depending on how severe the light pollution is.
Yeah, let's see. So a comment that I'm looking at right now is how far away is the comet now compared to the planets, and how close to the sun will it get compared to Venus and Mercury?
So the closest approach to the sun will be a quarter of an astronomical unit. Let me go grab my phone real quick, and I'll tell you what the distance is right now to Earth.
Sounds good. And while you're grabbing that, I'm also going to tell people once again that Cheshire just spammed the link to Astronomy Live's YouTube channel. He also does rocket launch videos of much higher quality and precision than me. So please go over there and subscribe, and also go there to subscribe for his deep sky observations. He knows what he's doing. He has the equipment for it. He has the knowledge to back it up. He knows what he's doing. So please go over there, subscribe, hit the bell icon, all that good stuff. You will not regret it.
And Red, I'm going to send you another link in Hangouts here.
Absolutely.
Um, so there we go. This is a photo I just took of, well, a few minutes ago anyway, back when I took that 4-minute exposure with my cell phone. There's me sitting at the computer with the telescope there tracking the comet.
Absolutely, absolutely. Let me go ahead and bring this up so I can show everyone. And let's see. All right. And it is okay to go ahead and share this image, correct?
Yes, yes.
All right, perfect. So let me go ahead and download this image. All right, we are showing the image right now. So this is you, all ghostly because you're moving, but
Right.
but that is your telescope pointing at the sky. That is you at the computer working your magic. So that's what you're doing right now.
Yes, exactly. And you can see the moon setting in the trees there. You can also see Orion about to set in the trees. The little streak of light that's up there is actually just a reflection, probably coming off my hat. You get some weird reflections with the Pixel 4, where really bright stuff will appear in the opposite side from the center of the image. So that actually might be a reflection of the computer monitor. That might be it. But something bright there is reflecting in the sky. That's just an artifact of the camera.
And just to be clear, this was taken with your cell phone, the Pixel 4.
Yes. Yeah.
That camera is just amazing.
It really is. It really is. It's so fun to just take quick shots like this and really be able to see the stars. I mean, you can even see the Orion Nebula there in Orion, clear as day. That's really cool. If you want to, you can even zoom in on that and get a look at it. Um,
That
but
is absolutely neat. That is absolutely neat how it is. And also with another question that they were having, I wanted to ask it to you right now. How often do you stream to your channel?
I try to aim for at least once a month. This month, I've been streaming like crazy because, home isolation and all of that. I'm working from home, so I don't have to commute, which gives me more time in the evenings to get set up and do streams. But usually it's closer to once a month.
There you go, guys. So, like I said, Astronomy Live knows what he's doing. He's the guy you want to subscribe to. So please go ahead and do that. And we're also going to be ending this live stream in about half an hour. But the show's not over. We are going to be transitioning to Astronomy Live's channel for the remainder of the night. So we're just setting the stage on my channel, and then we're going to move over to his channel to continue on from there.
Yep. So the current distance of the comet is 1.05 astronomical units, 1.055 according to Sky Safari Pro. So that's just a little bit more than the average distance to the sun.
There you go. How does atmospheric temperature affect picture clarity?
So atmospheric temperature plays a role in a couple of things. One is how much heat turbulence you tend to get, especially off the ground, off the rooftops. I'm not really looking over any rooftops with the telescope right now, thankfully. But obviously, the colder it is, the less turbulent you tend to get. You still can get higher atmosphere turbulence that can distort the image and degrade the quality. The other thing it drives is how cold I can run the camera. So right now the temperatures are warm enough that -5 degrees Celsius is easily doable, but if I wanted to push it really far down, I really couldn't push it down to -15 or anything like that. At this point, it's starting to cool off a little bit tonight. I probably could push it down to -10. So the colder I can push the camera, the less thermal noise appears in the image. And that's just a function of how hard I can push the cooler to get it down to these really cold temperatures. But even as it is now, -5 degrees Celsius, that's pretty cold. I mean, it definitely takes out most of the thermal heat that you see. If you're just running a warm camera like an SLR camera, You just have to live with that. You're living with warmer CCD temperatures as the camera runs. If it's not actively controlling its temperature, it'll tend to warm up as well, just from the heat of the batteries and the heat of the camera itself. And this degrades the image quality, especially for very faint objects like the tenuous outer portions of the comet's coma and the tail.
And we have two additional questions. So the first question is, can I see it in the southern hemisphere tonight?
Definitely not. Pretty much not. This comet is very far in the north right now. The declination is positive 68 point, almost 68.5 degrees, and so it's very far in the north. It's in the constellation Ursa Major. So if you can't see the Big Dipper, you can't see this comet.
Got it.
Um, and in fact, it's so far north that it was challenging tonight to set up the scope. In fact, I should go check it right now because the cables wanted to get pinched. I took off the focal reducer I had on last time. Last time I streamed this comet, I had on a focal reducer, which pushes the camera a little bit off the back of the telescope. And I was just barely able to fit the cables between the wedge and the camera when it was traveling that far north. That picture that Red just showed you there, the camera, you can see how the telescope looks like it's almost perfectly in line with its own fork arms. And when it's like that, the camera is basically forced down into the area between the telescope and the wedge. And there's not a whole lot of space down there. So as it
Yep,
gets
I'm
further and
zooming in
further,
on it right now. So, uh, for those of you who don't know how equatorial telescope mounts work, just a brief description. There's the altitude and then there's the azimuth of the scope. So the azimuth is the axis of the azimuth for the mounted scope is aligned with the celestial pole, correct?
so when it's mounted equatorially, it's no longer called azimuth. It's actually now called right ascension.
Right ascension. There it is.
Mm-hmm.
I see.
And then
Because your telescope is a shapeshifter. I forgot about that.
Right. Yeah, my telescope is now polar aligned, so it's now right ascension, and then the altitude dial actually now becomes declination.
I see. Well, you can see how the forks are aligned there, and the scope is almost aligned with the forks.
Right.
So that's like really close to like a Polaris, right?
Yeah, exactly. So the the closer you get to the North Celestial Pole and Polaris, the more that becomes aligned with the arms. You can also actually see the cables coming off the bottom of the camera in this shot, and you can see how they're running right past the wedge. So if
Mm-hmm.
you zoom in a little bit more there, you see what looks like a phone cable, and you can see what looks like a serial port attached to the bottom of the camera.
Yeah.
And then you got the white cable there, that's the USB cable, and the black cable, it's harder to see, on the right bottom side of the camera. The camera is the thing with the fan and the red light on it. And so that is the camera hanging off the back of the telescope. And those cables don't have a whole lot of clearance between the bottom of the camera and the wedge. And so anything that pushes that camera down more, like the focal reducer, really starts to pinch those cables pretty bad. Last time I was just barely able to get away with it, but the Comet is now a degree higher in declination than it was last time. So I've had to forego the focal reducer. So we're actually zoomed in more than we were during my previous webcast.
And and again, I think we already answered this question, but we're going to ask it again. Is the cooler similar to liquid cooling or some kind of thermal pipe cooling or phased cooling?
So it does have a liquid cooling option. It does have a radiator sort of system in it, and you can run water through it. It does have a water cooling capability, but I've never actually used that. Right now, it's air cooled, but it has a thermoelectric cooler that's on the CCD itself. So it uses electrical power to create a temperature differential that makes the CCD very, 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 very cold. -5 degrees Celsius right now, even on a relatively warm Florida night. The warm side of that plate is then dumped. That heat is dumped overboard using a Peltier and fan system that rejects the heat that way. So it's effectively air cooled, but the CCD itself is thermoelectrically cooled.
And they said for another one, Astronomy Live at Red Strike, what would be too cold for your use of these optics tonight?
There really isn't much of a limit there. I mean, this thing can run in pretty darn cold temperatures. Um,
Actually, is it true that the colder the ambient air, the better?
To a degree. Now, I've heard, and I've living in Florida almost all my life. Like I've never personally experienced this, but I've heard that these telescopes, start to have a problem at a certain low temperature, like sub-freezing temperature, where the grease that's on the gears kind of gets gummy and the gears aren't properly
Ah.
lubricated at that point. So there is a limit, but that's more mechanical than anything else.
And telescopes like that are about 40 to 50 minutes to set up, plus about an hour or two to cool down. So let me ask you this. You have a completely blank yard, you have an extension cord, and that's it. How long would it take you to set up from start to your ready to live stream? And these are the images we're looking at.
I started setting up tonight at 7 p.m. and was basically ready at 9 p.m. I was running a little bit late. I did take a slight detour where I took that photograph of the moon, which added a little bit of time, but just a couple minutes. And then I had some issues just double checking the alignment of the scope and making sure we're able to get on target. But yeah, it takes me basically 2 hours to set up.
And for rocket launches, how long does it take you to set up for those with your telescope and tracking these rockets? How long would it take you to set up your scope upon your arrival?
So there, I like to leave myself at least an hour of time. It doesn't take nearly as long because I'm not polar aligning the scope. I'm not having to carefully align it parallel to Earth's axis of rotation. I can just throw it on the tripod in alt-az mode, which is a lot faster, and get on the rocket. But it still takes me. I think the fastest I've ever done it was 45 minutes, and I was really in a crunch there, having to trim all the bells and whistles out and just do the basics.
Now, how do you power your setup when you're on location? Because there's no access to a wall outlet anywhere. We're in the middle of a dirt lot. So, how do
Right.
you power your setup? How do you power the scope, the controllers, and stuff like that?
So I power it with lithium batteries when I'm on location. When I'm at the rocket launch, I've got two large lithium batteries that each have 300 kilowatt hours, I think. Or no,
Not
not
not not
not
kilowatt
kilowatt
hours.
watt hours. Sorry, what? Not kilowatt. I wish it was 300 kilowatt hours. No,
Yeah,
300
that's
watt
that's
hours
that's
of
three
power.
times the Tesla Model S right there.
Yeah, right. I wish it was 300 kilowatt hours. No, 300 watt hours. Sorry, of power. That's still significant amount of power there, and will easily run the scope all night long if needed. And I use that if I have to go remote as well. So I can drive out somewhere really really dark and set it up that way and run off the lithium batteries.
And those batteries, you said once again, they can last you all night, correct?
Yeah, basically all night. I mean, the only thing that can be a limitation is if I'm running my laptop. If I'm running my more powerful laptop, it is more of a battery hog, and it will. I'll use one of those batteries just to run the laptop, and it will drain that battery after maybe four hours or so. If I use my weaker the more pathetic laptop that's actually running the camera right now, this is a much lower power laptop, which is actually a good thing when you're wanting to get a lot of battery life. So I can run that all night.
And when you are filming the rockets, like for just a single launch, do you
Mhm.
have everything powered on all the time, or do you start flipping on certain aspects of your setup just before launch? Like, do you keep everything like shut down for the most part until like T minus 10 minutes or something like that? How do you like get everything ready to go, or what's the
So
time frame as far as getting everything ready to go?
with the laptop and the telescope itself, I try to power those on as quickly as they're ready to go. The batteries, the lithium batteries, will run those, for hours and hours. So that's not really usually a concern unless we have a really long launch window. So I will usually power those on well in advance. The camera itself, the Canon T5i, I'll wait till just before launch to turn that on.
All right, all right. And another question is, do you use this rig for solar observations?
Yes, sometimes I do. I do have a Thousand Oaks optical solar filter, just a white light filter that I use with this telescope. I used it for the 2017 total solar eclipse. Went up to Wyoming with the scope and filmed the total eclipse from there.
And for those of you who remember, we also live streamed on this channel, which has since been, I believe, re-uploaded onto Astronomy Live's channel. We also did the transit of Mercury. Of course, it wasn't all that good because I was an idiot and didn't take into account the trees. So part of that was from the Nikon P1000, but your scope was here at my location, and we did a live stream from your scope.
Yeah, yeah, that's right. I
And
don't know that I uploaded that to my channel. Oh, it doesn't matter. It's on your channel for sure.
yep, it's there. If people would like to see it, I can grant access to it again. But for this particular observation, I just want people to understand once again, we are taking long exposure shots. This is, if I remember correctly, 2 minute long exposures.
2 minutes. Yep,
All right, and at the very end of it all, you're going to put this into kind of like a time lapse style video.
absolutely. Time lapse and a stacked photo as well.
And now, are you going to do that at the end of multiple nights of observations, or do you do that like every single night?
Depends on if I plan to reobserve it again very soon. So I probably I'm going to be busy for the next couple of nights. I may not be able to get back on it again right away. So I'll probably just do a time lapse from the images tonight on its own sometime tomorrow.
Perfect, perfect. Then for people who are wondering, please go to Astronomy Live's channel and hit subscribe. Cheshire Vic just posted the link to his channel once again. Once you're there, hit the bell. This guy knows what he's talking about, and people don't really know this, even though I try to tell everyone all the time. Astronomy Live is the reason my current setup works for tracking rocket launches. His software runs on my laptop, which makes everything work. So the most recent launch that happened, which was Starlink 5, that was only possible because of Astronomy Live. And when I posted on Twitter of the testing that we were doing, that was at his house, and he was the one doing all the diagnostic work to make sure that everything was working. So Astronomy Live is the man. Please go to his channel and subscribe. You'll be doing me a favor, and you will also be getting this guy some views that he definitely deserves. He is undersubbed for what he is offering the YouTube community.
Oh, thank you, Chesh. Chesh is going on a rampage with that link.
Yes. And when she says don't ignore me, you better listen. So yes, please go there, hit subscribe, hit the bell icon, and you will not be disappointed. And also going there, you'll see the time lapse, the processed images after this night of observation is concluded.
That's right. Yep.
Now for this one, let me go ahead and ask you this: do you use any filters with your current setup? I'm guessing they mean optical filters.
Yeah, they mean, I don't know if they mean like narrowband filters or color filters. No, the camera itself is a single shot color camera. It has red, green, and blue pixels, just like any consumer camera would. It uses the same CCD. Kodak, I believe, made it originally. They don't make it anymore, unfortunately. But same CCD that is found on the Mars Curiosity rover and the Mars 2020 rover. So the panoramic cameras on the Mars Curiosity and 2020 rovers uses the exact same CCD that I've got here. Um, the filters, as far as filters go, with the adaptive optics unit attached, I actually have to remove the threaded part where I could normally mount a 1.25-inch filter to the front of the camera directly, like an infrared blocking filter or a hydrogen alpha filter, anything like that. I actually remove that ability by attaching the adaptive optics unit, but it's a good trade-off. So I don't actually have a way of using filters with this. If you buy a separate filter unit that SBIG makes, you can attach that between the camera and the adaptive optics unit, but I do not have that. So no, I actually have no way of using filters right now, the camera in its current configuration.
Another question that someone was asking is, what does the future look like for your setup? Are you going to be making any upgrades? Do you want to get a whole new scope, a whole new camera? What does the future hold for Astronomy Live's setup?
So the one thing I would like to upgrade at some point in the near future is the white telescope that you see on top, or actually in the current pointing direction, it's on the bottom of the telescope. That's a wide field refractor, an Orion ST80. It's just a simple achromatic refractor. It's not very fancy, and the optical quality is not great on it. I would like to replace that with an APO at some point, an apochromatic refractor. Probably an Orion ED80 is kind of the one I've been eyeing. It's tried and true, and good optical quality for taking wide field pictures. So I'll probably replace that white scope with an Orion ED80 or something along those lines sometime in the near future. That's the next path for upgrade.
What about a like a bigger scope, or is what you have right now? You're just going to push it to its absolute limits, regardless.
I'm probably gonna keep using the same 8-inch scope for as long as I possibly can. It is a pretty good scope, and I have manhandled around the 10-inch model. If you go to Everyday Astronaut's channel, the scope he's been using to track launches, he's been using my software as well, and I actually put together that scope for him, provided by OPT Telescopes. They shipped it over to me, and I put it together and got it ready for tracking. And yeah, I can one man it. I was able to get it up on the Altaz configuration, but that thing is heavy. Even though it's only 2 inches wider in diameter, it actually increases the overall size of the scope because the focal length is also longer, so the overall tube is bigger. The actual, area and volume of the mirror is a lot heavier. It is just a beast, and trying to get that up on a wedge would be kind of dicey. Like, I can easily mount mine on the wedge, like I did today, but trying to do that one man on a wedge with a 10-inch scope, I'm not quite strong enough to feel completely confident in doing that safely. So, no, I don't have any plans for upgrading the size of the scope anytime soon. Certainly for not for doing this kind of stuff, for doing deep space stuff. So, the next path for upgrade really is along the lines of a wide field refractor that's really high quality optical, really high optical quality. Even though the scope isn't physically impressive looking, it's not big. You can get really nice pinpoint images, really beautiful wide field photos. A lot of nebulae that are interesting to photograph, like the Rosette Nebula, the California Nebula, the North American Nebula. I could go on and on, are really not ideal for photographing with my main scope because my main scope has a very tight field of view. The full moon would not even fit in the complete picture that I'm taking right now. And we're only looking at a portion of the complete picture I'm taking right now. So it's a very high magnification view. And so you miss out on some of these really large structures, really large nebulae in the sky. And you need a wide angle, smaller refractor for that. But you want really high optical quality too. So that's really the most logical path for upgrade for me in the near future.
Oh, then we can't wait to see what it'll. I can't. I personally cannot wait to see what that upgrade does for your overall setup and the overall quality of your images. And also, I want to say hi, Slice Barcane. How's it going? What you're seeing is what Astronomy Live is seeing through his scope after a 2 minute long exposure.
Yep, we're tracking this comet live.
This is live, ladies and gentlemen, boys and girls. Astronomy Live is doing the smart person stuff, so you don't have to.
That's the idea.
That is the idea. And like I said, we are going to be closing out this hangout in about maybe 10 minutes. But the show is not over. We will be moving on to Astronomy Live's channel. And Cheshire has done a fantastic job of spamming the link to his channel. So please go over there, hit subscribe, hit the bell icon, and then you can continue watching from there. And when you're in the live chat, tell Astronomy Live that Red sent you.
That's right. Absolutely.
That's how we do. That's how we do stuff here. And a lot of people are also saying a certain thing that you are teaching them quite a lot. So I guess one of the questions that I would have is, how long did it take you to learn all of this? How did you learn all of this? What did you find a book in a dumpster somewhere and you just started reading because you were bored, and then all of a sudden you became an expert? Like what happened?
Yeah, I started trying to teach myself amateur astronomy when I was in middle school. Gosh, that was a scary long time ago. And I wish I could remember the name of the book. I used to just read it cover to cover multiple times. I think it was called Through the Telescope or Looking Through the Telescope, something like that. I wish I recalled the name. And it just taught me the basics of sky coordinate systems and telescopes and polar alignment and all of that before I even really had a telescope that was any good. In middle school, I got my first telescope, which was just a 60 millimeter refractor, really, one of these really long tube, skinny little refractors. It was on a shaky little wooden mount. Not the best scope, but it got me started and really got interested in it, especially when I was able to find Saturn. Um, I think I found it by accident the first time. I mean, I was just pointing, hey, what's that bright thing over there? And it turned out to be Saturn. And once I saw the rings of Saturn, it's like, okay, now I'm hooked. Now I want a bigger, better telescope to see this even better. And so from there in high school, I ended up getting a 6-inch Newtonian scope. So this was, 24 years ago now, maybe 23 years ago. I bought a Newtonian reflector on an equatorial mount. It was on a German equatorial mount. Actually, it wasn't a Dobsonian. It was like a Dobsonian, same type of tube, but a cardboard tube with a mirror in it, basically a pair of mirrors in it. Newtonian design on an equatorial mount, and this thing was a beast to lug around because it was a cast iron, it's like a cast iron mount. I don't know. It was steel, metal of some sort, and had a clock drive. So it had gears that would turn that would try to track the movement of the sky, but it ran on like AA batteries, and as the batteries wore down, it would not track at the right rate. So it
Ah.
wasn't it was not as accurate as this. I couldn't do photography with it for sure. And then that was the next thing. I wanted a scope that I could actually do photography. I really wanted to get into astrophotography. So in 2004, I bought this scope, the LX200 Classic, and so I've had it now for close to 16 years, and almost right away started doing photography with it, and have tried many different cameras on this telescope, upgraded it in various ways with the refractor on the top and counterweight system, homemade counterweight system, and just got better and better at it until finally I've got the current setup that I'm really now quite happy with how well it works for deep sky work and tracking comets like this.
And we also have a question of comparison. So let me go ahead and find it again. I just have to go through all the spam. Okay, so image quality, reflecting versus refracting telescope. What are your thoughts?
So that's a great question. That reflecting telescopes like this that have a central obstruction. The telescope's mirror, the main mirror, is shaped like a donut. It's got a hole in the mirror, and the light passes through that hole to the camera. In the front of the telescope, there's a corrector plate, and there's a smaller secondary mirror that is like it would almost fit in the hole that's cut out of the primary mirror, and that passes the light through that hole. So that central obstruction, that secondary mirror in the front of the telescope, actually degrades the contrast of the image. So theoretically, a refractor that has no obstruction, just a regular lens, the same size as my telescope's mirror, should have a better contrast, better resolution, and capability. But refractors have another problem. They don't bring all the colors of light to the same point of focus. So you get what we call chromatic aberration, where you get color fringes, red and blue showing up at the fringes of whatever you're looking at. Now, with refractors, you can use multiple glass elements to attenuate that and compensate for it. And so you have apochromatic refractors that are really good at attenuating these color fringes. So those are really high quality, but they're also very expensive. So to get a refractor as big as my scope, you would be spending huge amounts of money, and the resulting lens system would be very heavy. So, it with refractors, you can get very high optical quality, but you pay a premium for it, and so you generally are going to be buying a refractor that's not nearly as large as my main telescope. But for wide field shots, that's all you need anyway, and you can get really high quality images. Technically, you can theoretically get higher quality images than what I'm able to get with mine, pound for pound, because of the high quality of the refractor's optics.
And for the last one we're going to do before we conclude, I actually have a question. Should we reveal our plan? between your scope and my scope and the use of parallax?
Ooh, should we?
I
I
mean,
don't
it's
know.
it's up to you. We can make it a surprise, or I can spill the beans right now. It's up to you.
Let's make it a surprise. Let's
So,
make it a surprise.
sounds good. So with that, we are going to conclude this stream. Guys, thank you so much for watching. Thank you so much for being here, and thank you so much to all of you who have went to Astronomy Live's channel and subscribed. We will be continuing on Astronomy Live's channel, so please head over there, and we will see you there shortly. Astronomy Live, before we head out, anything that you would like to say?
Just thank you again, Red, for hosting this, and yeah, just come on over to my channel, please subscribe, and we're gonna be watching this comet throughout the rest of the night, pretty much. So if you want to see this comet continue to move through the sky, it's gonna be on my channel.
All right, guys. Peace out. See you on Astronomy Live's YouTube channel.